Let's take a look at another functional equation. So it's from a mathematical high school competition in Belgrade 2004. So it is like find all function f from natural number to natural number such that f evaluated at f of n plus f of n equals n plus n for every two natural numbers m and n. So it's an interesting question. So if you can find the trick, you can solve it in a few steps. So first, we observe that on the left side, we can see f evaluate at the sum of the function, which means a composite function. So if we can prove f is an injective function, then we can simplify the left-hand side and find the solution quickly. So our first step is to prove f is injective. To prove this claim, we of course assume f of a equals f of b for ab is natural number, or natural number. So in this case, by making use of the original equation, we know that 2a equals a plus a, which is actually substituting m and n to be a in the original equation in star, so that we can have f evaluate at f of a plus f of a. And we know that f of a equals f of b, so that f of a equals f of b. Then we can write it as f evaluate at f of b plus f of b. So now we use the original equation again, but to substitute m and n by b in the original equation, so that we can have a b plus b equals 2b. So when you see the leftmost and rightmost for this equation, we can see that 2a equals 2b, which means a equals b. So that f of a equals f of b implies a equals b. So in other words, f is injective. So next, we can apply some trick. So for the original equation, we can substitute, let me see, m to be 2k, m and n to be k, m and n to be k. So we will have f evaluate at f of k plus f of k equals k plus k. And also in the original equation, we can also apply m equals k plus 1, n equals k minus 1. So in the original equation, we have f evaluate at f of k plus 1 plus f of k minus 1 equals k plus 1 plus k minus 1. So this is 2k, this is 2k, which means these two equation, the right side is the same, which means that the left side also be the same. So for these two equations, k should be larger or equal than 2, because we have a k minus 1 here. So we know that for the left-hand side, they should be equal. They should be equal. And we also know that f is injective, so that we can just, we have f evaluate at f of k plus f of k equals f evaluate at f of k plus 1 plus f of k minus 1. So we can apply f inverse on both sides because f is injective. So now we can cancel f and f inverse so that we have f of k. 2 times f of k equals f of k plus 1 plus f of k minus 1. So this is a very good expression, very tiny expression. So we can slightly rearrange it. So we have f of k plus 1 minus f of k. So by moving one of the fk to the right side and move the fk minus 1, f of k minus 1 to the left side, so we will have f of k plus 1 minus f of k equals f of k minus f of k minus 1. K is larger or equal than 2, and k should be should be a natural number. Of course, or you can say a natural number excluding 1. So now we can know that for every, let's say, f of k plus 1 minus f of k equals, let's say k equals to k equals 2, which means that we have a f of 2 minus f of 1 for all term, which means that this should be a constant. This should be a constant. Or in other words, the difference between every two adjacent terms should be a constant, which means that f should be a progressive series, progressive function, function, or linear function, or a linear function. So we can assume that f of n equals let's say, maybe we can use an plus b, and we substitute this into the original f, evaluate at f of m plus f of n equals m plus n. So in this case, f of am plus b plus an plus b equals m plus n. So on the left side we have a times a m plus n plus 2b. So this is this one plus b equals m plus n. So on the left side we have a square m plus n plus 2ab plus b equals m plus n. So comparing the coefficient, so this is multiplied by 1, which means that a square should be 1 and 2ab plus b should be 0. So from the first identity, we know that a should be plus or minus 1. However, for the negative sign, it will make the function to be a negative value, so that minus 1 is rejected. This will lead to negative value. So in this case, we have 3b equals 0. So we have 3b equals 0, which means b equals 0. So the solution will be f of n to be n. So this is the solution. So let's check f of f evaluate at f of m plus f of n equals f of m plus n equals m plus n equals, so this is the left side equals the right side. So this is the end of this video.